Good day and welcome once again to our class. In today's class, we want to look at how to determine whether a sequence is monotone or not. We begin with the example. Given the sequence a sub n defined as 3n over n plus 2. Prove that it is monotonic. We want to prove that it is monotonic. The first thing is to recall the definition for monotonic sequence. A sequence is monotone if it is either increasing or if it is increasing, then what? A sub n plus 1 will be greater than or equal to a sub n. And if it is decreasing, then a sub n plus 1 will be less than or equal to a sub n. Now for this sequence we are given, let us go ahead to consider the terms of the sequence. For our sequence a sub n, a1 will be what? A2 will be what? 3 into 2 over 2 plus 2. That's 6 over 4. And that is 3 over 2. A3 will be what? 3 into 3 over 3 plus 2. That is 9 over 5. A sub 4 will be 3 into 4 over 4 plus 2. And that is 12 over 6. That is 2. What does that tell us about the term of the sequence? Term is 1. Our second term is 1.5. Our third term is 1.8. Fourth term is 2. And it will continue like that. It shows that an is increasing. But for us to be sure that truly an is increasing and not a sequence that will initially increase and then decrease, that is the eventually decreasing sequence, we need to ascertain that our a sub n plus 1 is greater than a sub n. We need to ascertain that a sub n plus 1 is greater than a sub n. From the sequence, our a sub n is what? 3n over n plus 2. And so a sub n plus 1 will be 3 into n plus 1 over n plus 1 plus 2. 3n plus 3 over n plus 3. Now I want to show that a sub n plus 1 is greater than a sub n. That is 3n plus 3 over n plus 3 is greater than or equal to 3n over n plus 2. When we cross multiply that, we have what? 2n plus 2 to be greater than 3n into n plus 3. This gives me what? 3n squared plus 6n plus 3n equal to 3n squared plus 9n. We have what? 3n squared plus 9n plus 6 to be greater than or equal to 3n squared plus 9n. When we cut the cuttables, we have 6. A sub n plus 1 is greater than a sub n. And we can say that truly the sequence a sub n is monotonic increasing. It is monotonic increasing. We'll take another example. Consider the sequence a sub n defined as what? 3/4 raised to power n. Show that it is monotonic. Again, I said that the first thing we need to do is to recall the definition for monotone sequence. A sequence is monotone if it is either increasing or decreasing. It is either increasing or decreasing. And if increasing, we expect that what? A sub n plus 1 to be greater than or equal to a sub n. If it is decreasing, we expect that a sub n plus 1 to be less than or equal to a sub n. Now let's go and consider the terms of our sequence, so we can have an idea of whether the sequence a sub n defined as 3/4n, whether it is increasing or it is decreasing. Considering the terms of the sequence, when n is equal to 1, a1 will be what? 3/4. a2 will be what? 9/16. When n is 3, a3 will be what? 27/64. When n is 4, a4 will be what? 81/250. That will be 0.75. Our a2, 0.5625. a3, 0.4219, and it continues like that. We can see from here that the sequence seems to be decreasing. Now, for us to be certain that this sequence is actually decreasing, we need to make use of this. A sub n plus 1 is less than or equal to a sub n. Our a sub n is 3/4 raised to power n, and our a sub n plus 1 is equal to 3/4 to power n plus 1. An equivalence for this is a sub n plus 1/a sub n to be less than or equal to 1. Since I have powers, I want to make use of this equivalence. So my a sub n plus 1, which is 3/4 to power n plus 1, is the same thing as what? 3/4 to power n times 3/4. Therefore, a sub n plus 1/a sub n will be 3/4 to power n into 3/4 divided by what? Our a sub n, which is 3/4 to power n. This removes that, and we have a sub n plus 1/a sub n to be equals to 3/4, and that is 0.75. That means a sub n plus 1/a sub n is less than 1. We can take another example. Consider the sequence a sub n defined as what? 1/n squared. Show that it is monotonically increasing or decreasing. we want to show that it is monotonically increasing or decreasing. Remember we said that a sequence is monotone if it is increasing or if it is decreasing. And if it is increasing, a sub n plus 1 will be greater than or equal to a sub n. And if it is decreasing, a sub n plus 1 will be less than or equal to a sub n. Let's consider the terms of the sequence. What are the terms of this sequence? A1 is what? 1. A2 is what? 1 over 4. A3 1 over 9. A4 1 over 16. A sub n plus 1 less than or equal to a sub n. First, what will be our a sub n plus 1? That will be what? 1 over n plus 1 square. We want to show that a sub n plus 1 is less than or equal to a sub n. 1 over n plus 1 squared to be less than or equal to 1 over n squared. If we cross multiply, we have our n squared to be less than or equal to what? N plus 1 all squared. And that gives us n squared to be less than or equal to n squared plus 2n plus 1. And so our 0 is less than or equal to 2n plus 1. So therefore, a sub n plus 1 is truly less than a sub n. And that tells us that this sequence is monotonic decreasing. That tells us that the sequence is monotonic decreasing. You can try your hands on the following. Note that for this one, your a sub n plus 1 will be what? 1 plus 1 over n plus 1 to power n plus 1. So try your hands on those two, and if you are able to solve it, you leave a comment in the comment section. If you have gained anything from today's class, or if you think that what we have done today is useful and you have benefited from it, give the video a thumbs up, like it, and share with your friends and colleagues. Thank you. God bless you. I see you in the next video, where I'll be talking about the monotone convergence theorem.